This week, the space station flight control team members are preparing for something that they've never done before, and that will be the first ever grapple and berthing of a commercial cargo vehicle installed to the International Space Station. For that operation, all of the team members will have a certain special set of responsibilities that they have to live up to in order to get a successful completion of that task. And we're going to learn about one of them in particular here this morning. Our guest is Brandon Moncla. He is the lead operations support officer for the SpaceX Demo Mission. Brandon, it says here that the OSO is responsible for all station structures, mechanical systems, and systems maintenance. Seems like an awful lot of things to be responsible for. Are you like the superintendent of a building responsible for making sure that things are working?
Yeah, Pat, that's actually very close to what we do. In addition to our structural and mechanical systems that we're responsible for operating and maintaining, we also have to coordinate the maintenance of all of the other systems that are being operated by the other flight control disciplines, whether it be electrical systems or CDH systems or life support systems.
On a day-to-day basis, how do you keep track of all of those different things? What is it that you do to make sure that all those different systems are still working?
Right. So as system failures occur, each of the various disciplines will jump up and let us know, hey, we've got something broken that needs to get taken care of. And then we prioritize that list, working with the rest of the increment teams, what's going on, especially in having to prioritize that with payload operations and science stuff that's going on as well.
Now, I understand that your job is not just, if you can say, just the operation of all those systems. You also have a lot of responsibility when it comes to training crew members how to operate those systems.
Absolutely. So we spend a lot of time training the crew how to operate the mechanical systems, whether it be the common berthing mechanisms, one of our mechanical systems that we are responsible for operating and training the crew to operate. But on the maintenance side as well, we train the crew on what tools we have on orbit, how to use those tools safely and properly so they can perform the maintenance activities on board.
Let me get you to narrow it down specifically. In the case of this vehicle that's approaching now, the Dragon spacecraft, what are the OSO's responsibilities in terms of its systems and its interaction with the space station?
Okay, yeah, so for Dragon, as it comes up and approaches, it'll be captured by the arm, by the SSRMS. It'll be maneuvered to below the Node 2 nadir, the Harmony module, the bottom side. At that point, the arm will bring it up to the bottom side of Node 2 nadir, and we'll start the common berthing mechanism. So we'll be monitoring that, sending commands that will actually drive bolts to hold and capture the Dragon to the vestibule. At that point, that vestibule area between the Dragon and the node will be sealed off, and we'll be able to pressurize the vestibule. That's the mechanical side of the OSO's operations. At that point, we get back into the kind of maintenance side, hands-on side, where the crew will pressurize the vestibule. They'll go into the vestibule and mate power jumpers, data jumpers, some air sampling lines, and then we'll open up the Dragon hatch and ingress their vehicle.
Let me get you to talk a little bit more about some of those different aspects of it. The the common berthing mechanism, as it's known, and it's the same piece of hardware that other ships dock to and other modules have been attached to. But it's not just a passive thing that something sticks into. It has to be operated by the crew members, right?
That's right. We actually tag team between the crew and the ground operators on the ground. So for the initial latching and bolting of the two halves of the CBM. So the Dragon has one side that's got a set of passive nuts on it, and then we've got the actual bolts that we're driving on board the space station. So the crew and the ground send commands that drive those bolts into the Dragon vehicle, and that's what pulls the two halves of the vehicles together and creates that seal around the sealing surface.
So it's operated by the crew members, and the crew members who are doing that are working in coordination with the crew members who are controlling the arm that was carrying the Dragon in, right?
That's right. There's a lot of coordination involved. You've got a couple of robotics operators on the crew, as well as some of the crew pull double duty and do robotics as well as CBM operations. And then both the Robo and OSO teams here on the ground are also coordinating, commanding, and monitoring all that telemetry all at the same time.
Making sure that things are where they're supposed to be and that the systems are operating properly.
That's right.
Now, you mentioned a moment ago that after the two are put together, there's some work done in what's referred to as the vestibule. There is a space between the two vehicles once they're attached, right? What has to be done to prepare that space?
So once the CBM operations are done, we've mated the two vehicles together. They're structurally held in place. The area between the Node 2 Nadir hatch and the Dragon's hatch, that is still at the vacuum of space. So at that point, we'll give the crew a go to introduce air into that vestibule volume. That'll pressurize that area and actually allow the crew to be able to then physically open the Node 2 Nadir hatch. There's some hardware that has to be removed once they get the hatch open, some MMOD shielding, and some of the CBM hardware physically gets removed. At that point, they've got access to start mating those power and data and air sampling jumpers in the vestibule.
That area between them that starts out at the vacuum then has to be pressurized, and the crew members have to monitor that whole operation with your backup from the ground too, right?
That's correct.
Is the way you handle berthing of a Dragon and preparing to open its hatch, is it different, significantly different than what you do for other similar vehicles, other cargo vehicles?
Not too much different. It's very similar to what we've done for HTV-1 and HTV-2. I liken it to having just different automobile makers. You know, they all have to come up. The designs are very different, but they're performing the same tasks. They have to meet certain requirements, and they have to be able to interface with the station hardware that's already on board. So their passive CBM half are almost identical. They still have to mate to the same power and data jumpers. From there, for the Dragon hatch and the rest of their vehicle, it's very much different design and something that the SpaceX teams come up with on their own.
Yeah, of course, all of the designers knew what they were going to have to dock to, so they designed to fit it. But there are some differences that you folks can see too.
Oh, absolutely. Like I said, their hatch mechanism, the way it's designed, the way it operates, is very different from a US OS hatch. So the crew gets specific training on how to operate that hatch prior to ingress, so that they know how to operate the hatch to get into the vehicle and also for emergency situations.
In an emergency situation or in a normal situation, your team, your OSOs, have to work in coordination with the other teams. If there's an issue, they have to work with the discipline that's responsible for whatever system is having the issue, right?
That's right. For the space station systems, we have many procedures already published for what to do in case a specific piece of hardware fails. We know what steps need to be taken to access a certain box if it breaks, for instance. And so we'll go pull that procedure up, coordinate to get it on the timeline, and get the crew into repairing that box.
Anytime there's something that has to be fixed, whether it's scheduled maintenance or unscheduled maintenance, if you listen to Space to Ground talk long enough, you hear people looking for tools. Are you guys the ones who are supposed to know where all the tools are stored?
Well, we definitely gave a designated home for all the tools. There's multiple sets of tools on board, and the crew even has their own personal toolkits where we've flown commonly used tools, things that they use every single day, like ratchets and little hex heads that they keep in their pockets. But yeah, typically tools are kind of scattered. We've got 6 crew members on board doing multiple activities at the same time. Sometimes they're using the same tools, and so we have to work hard to deconflict tool conflicts.
To schedule the work so that there are sufficient tools for everything to get done.
That's right, and it always gets interesting, like you said. If something comes up missing, we're then on the hook to go find alternate tools that can also work.
That's entertaining. So is when someone finds a long missing tool. Somebody says, "Oh, guess what?"
Yeah, that always makes us happy when we find missing tools.
The kind of work that you've described that you folks are doing over there, it could be done by people with takes a wide variety of backgrounds. If I could use you for an example, tell me about your own educational, professional background. What does it take for someone to be an OSO?
Sure. Well, as an example, since OSO is responsible for maintaining so many different types of system and a wide variety of systems, all of the OSOs basically have some sort of a technical degree or background. Whether most of us are engineering, got some science and math majors as well. But beyond that, everybody has varying interests and varying experiences in life. And that allows us to have that well-rounded team. Me personally, I have a degree in mechanical engineering. on the training side that allowed me to develop my training skills. I worked a few summers for the Boy Scouts teaching fly tying and fly fishing through college, and that helped me with my ability to teach lessons and to train those skills. I also grew up in a machine shop. My dad had a machining company that built manufacturing equipment, so I have a good understanding of what it takes to manufacture things, how things are assembled, how they go together, and that definitely helps with a very complex space station.
Did you come to work at NASA straight out of college?
Yeah, I did.
Into this discipline, or did you start somewhere else and find some place to gravitate toward?
No, yeah, I actually came straight out of school, straight into OSO, and been here for 8 years.
Now you have something brand new on the way. I got a feeling that you folks are kind of jazzed about that.
Yeah, it's a lot of fun seeing all the new vehicles come up. I was able to work HTV-1 and HTV-2 as well. I was a lead for HTV-2 and then jumped over to SpaceX and helped out with the orbital team as well.
Brandon, thanks very much for taking a few minutes to help us understand better this aspect of this flight control team. Appreciate it.
Happy to be here. Thanks, Beth.
Brandon Moncla is the lead operations support officer for the SpaceX flight. You know, the inaugural flight of the Dragon is part of a NASA plan to reduce the expense of supplying the International Space Station in order to free up other government resources to help us prepare for the next steps in space exploration.